Alrighty, another day with the spider circuit, and today I'm putting the spider circuit onto the board. So I just started trying to figure out which is the best direction to lay this out, and I'm going to put this onto the au-d7 Sansui display board. So when I get some new ICs, I can turn the brightness up and down on the new display that I put in. So I'm kind of thinking this right here was the sweet spot. So I just hollowed this out so I got enough room to get this top screw in. So I'm going to put this across there, put some standoffs on it. I marked out some of the points here because I want to come down and hit pin 2 on this IC with the output of this board, and I want to come down and hit pin 2 on this IC with the other section of the output. So I just got to finagle the transistors on here. Looks like I'm going to pull a ground connection out of here, which is going to drop down to this one. And then if you superimpose this board over the bottom board, that puts our power somewhere up here where the power comes in on this last pin here. So I'm going to set this resistor there. And that's the general thesis. Make this and another mess just like it go into this. So I got some of this together here, which equates to 1/2 of it. Kind of like one little tip for those that maybe never messed with building circuit boards before that might turn out to be helpful. When you're doing this kind of stuff now on a single-sided board like this here, it's generally best if you try not to solder down to the pads, because if you ever get it or ever have to get this apart, you could, really pull your hair out trying to vacuum the solder off these pads. And this isn't the worst board by far. So what I've learned to do over the years is just to tack them down at the joints and try not to tack them where the solder pads are, to the most extent that I can anyway. So you see I didn't bother to tack it there, but I ran it across and tacked it there. And even these I didn't tack down. And even the center point really didn't have good flow onto the pad below it. So I do that purposely, and you can see I did the same thing here. They're not flowed the whole way down onto the board. There's a couple that are. But just a little helpful hint when you do this, otherwise it can be a real bear to get apart. Alrighty, so got this all put together. That's what the back came out to look like. And that's what we got there. So put 13 volts onto this. There, 1.09. To 623 millivolts. Pretty close, 621 millivolts. To 1.1, and this is kind of the upper ceiling. I definitely don't want to go above 1.1 on this. So that looks pretty promising. So I don't think that I can do any more with this until I get the new IR chips. So I'm going to add this back into the equation. Someone may look at this video and say, oh my, that is a lot to go through just to be able to turn the intensity control up on your LED displays. And I'm sure you're probably right by that. You know, I could have just went out and bought some low voltage regulators and made them adjustable, or I could probably just simply have just put a pot on it and just turned the pots themselves up and down. I'm sure that would have worked. But see, my theory with that is a little bit different. If I would have done that, that would have been really, really simple. You know, maybe I have a high parts count, but you know what? I built something. And, you know, that's just the way I look at things. So I just wanted to throw that in there. Half the fun of building something is cleaning up the mess. So I have a whole pile of parts from my spider circuit to try to relocate back into. This is the schematic. What I did, I'm not even sure if I showed this or not, honestly, earlier. Originally I had this set up for a 100K pot, and I didn't want to wait until I got other pots, so I tried to find a way to manipulate this transistor with a 20K there, and that worked out to be okay. So I just ended up using a 20 here. These went down to 4.3, these went down to 27s. I couldn't find any more 1 mics, so I just ended up using 4.7s, which is a lot of capacitance on a base connection, especially considering it's a tantalum. It wasn't ideal, but that's what I had. And actually this is still standing at 560 because I couldn't find a better alternative. And I hung a 100 mic across here. So that's what it turned out to be. Another thing too is I like to try to preserve continuity the best that I can. And you know, you don't always succeed at that. But you know, if I could find a way to put some 2SC 1845s back into Sansui's amp to utilize something else, it just seemed like a good idea to do that. So that's the secondary reason. So I appreciate you watching. Have yourself a wonderful day.